All right, I wanted to go over this project I've been working on. Basically, the whole idea is that Jehu's scooter batteries, they need a serial signal sent to them in order to activate the BMS. But also, they send back a 36-byte status message that has a ton of information. And I would like to have a device that could read all of that, log it, either send it off to a server somewhere or log it locally and then display it on a web interface and just visualize that data somehow without any additional hardware. So what we've done here is I have an ESP32, which is a Bluetooth Wi-Fi chip. It's similar to the ESP8266, just a little better. Dual core, more memory, I think. Yeah. And what this is basically is a serial port expander for the ESP32. What we have here are 8 serial ports. And so each transmit port is tied to the transmit on the ESP32, and through these logic gates and these cheap components, the ESP32 is able to read each RX port individually. Now, what's cool about this is that through this output expansion port, you can take a cable like this. Let me go backwards. And you can plug it into one of these expansion boards and you get another 8 ports. And you can keep daisy chaining these devices. Theoretically, the number is extremely high of how many devices you can daisy chain like that. I've never tested it. I've only tested 2 so far, but yeah, theoretically, there's a really high number of devices you can do this to. And so another great thing about this solution is that all these components here are super, super cheap Jelly Bean, super common components. There's just inverters, AND gates, shift registers, that kind of thing. So yeah, these boards are really simple to make, really cheap to make. Basically, let's take a look at one. If we take a look at this one, we have the ESP32. This is the programming header. It's just got the serial inputs, power, and ground. This is the boot header. For those of you who are experienced with ESP32, you just short these pins out when you connect power and it puts it into the boot mode, and then you can upload your file system, you can upload your firmware via the serial port. This section here is the power. It converts power from this port down to 3.3 volts. I forget what the voltage range is for that buck converter, but I want to say it's like 12 volts to 50 something volts. So it's good for the voltage range of the batteries, the scooter batteries. This is your reset button and power LED, and then there's also just a status LED. It's tied to GPIO number 2. I've left all of these unused GPIO ports broken out like this for, I don't know, future hardware. Maybe you could put a little OLED screen on this, or control some other relays or some other system. I don't know. That's for the future. And then all these components here are just the serial port expansion circuitry, I guess. And then of course the expansion header, where you connect. It's just a 10-pin ribbon cable. And that connects to the expansion device, which has the same ports, same components, and then another expansion header. Okay, now if we pull up the web interface on a computer, this is just the IP address of the ESP32 on the network. I'm working on using, I think it's called MDNS, to just change the name to something you would just type in, like batterylogger.local, and that would come up with the same IP address. But this is the interface. It's super crude right now. I just wanted to walk through it real quick. We have gauges up top. This is kind of the state of charge gauge. It's got state of charge or voltage. keep it at that. This is kind of like the power state. So what this is the average of all the batteries connected, and this is the sum of all the batteries connected. So right now we're pulling a tiny bit of power out of the battery to power the ESP32. That's what that is. There's only one battery connected right now. So you can do total current, total power. The scales are kind of messed up right now. This is really crude. Like I said, it needs work. And this is kind of like the status of the battery, I guess. So this monitors the voltage differential between the cells, and so this is the maximum voltage differential in any of the batteries. It's 0.01 volts. I should probably make that in millivolts. Like I said, really crude. And this is the maximum temperature that the internal sensors are reading of all the batteries connected. Below that, we have our plots. And so right now, we can plot three things: the state of charge, the voltage, or the current. Right now, I have state of charge being plotted. It's a little goofy with the animations right now, but it does work. You can see that I have had one battery connected. I did a little bit of charging, and then I stopped charging. And then for a little short, about a minute, I had another battery connected. These labels are wrong. They're kind of wrong. I'll explain that a little bit more. You can see I can do voltage. That looks a little bit more like a charge curve, kind of, and some weird stuff happens. Current. You can see I was charging at 4 amps. The sign convention is a little goofy because it's however you want it. I'm still playing with that. I decide how I want to do the negatives and positives current. But I'll set that back to voltage. And then last bar is we have just a list of all the batteries connected and more or less like the raw data that the batteries are showing. You can see, so port 1A, the state of charge is 29%. Voltage current, the highest voltage within the BMS, the lowest voltage within the BMS, and then the high minus the low basically is what the delta is. I should probably make that millivolts and get rid of some of the digits, but it is what it is. And then the temperatures. So each BMS has 4 temperature sensors, and those are those temperatures. I don't know why this last one is always high. It always is high. I don't know what's going on there. And then I'll show you in a second, but once you have more batteries, this interface highlights the lowest in each column and the highest in each column. I'll show you that in a second. What I want to do first is plug in the charger and just let the plot populate for a little bit. So let's go ahead and do that. All right, I've let the charging go for a little bit. You can see the graph. The voltage has updated. Looks like a typical charging curve. I'm not gonna let it go to full because I got other stuff to do. State of charge has gone up. The voltage has gone up. We're still charging at 4 amps. Let me unplug that actually. And this changed to the delta, but let's put it back to temp. Temp is about the same. The only other thing I wanted to demonstrate is that if I plug in the expansion board, I have a second battery attached to, it'll come up as port 2B. So I just plugged it in. Let's see if that actually works. Yep, there it goes. So port 2B, this battery's at 100%. Obviously the power is not connected together to the other one. Otherwise they'd be rapidly trying to equalize. Full voltage, no current. The high cell and low cell are there. The delta's there. And so that's what I was talking about with the lowest and highest. There's only 2 batteries connected. So there's, obviously this is the low and this is the high. If there were 3 and there was one in the middle, it would not be highlighted. And yeah, you get the idea. You can see the battery 10 just showed up on the plot. It's at a full voltage. Like that shows state of charge. It'll be about the same looking. Once this loads, it takes a second. Yep, there it is. So the new points should connect over. It's at 100%. And then this is what I was talking about earlier. This is the average voltage. So the average of the two voltages is somewhere in that area. And the average state charge is 69%. That's not going to look any different. And you can see the max delta is now 0.022. That's from our port 2B battery, not from the port 1A. So yeah, that's about it. There's some settings. You can clear the logs. You can change how many expansion devices are present. There's provisions to do auto detection, but it doesn't work quite yet. I'm sure I'm going to make more settings. You can reset the graph view because you can pan and zoom and all that stuff. That's about it. This is, like I said, it's a super crude interface right now. I have a lot of features I want to add. I want to clean up stuff like that. I'm happy to take any suggestions for this. I'd love to hear what people could possibly do or would want to see features added. I'm not really sure what the future of the project's going to be. I don't really want to mass produce and sell these things, so I got to figure that out. But right now I'm just developing this for me, and we'll see what the interest is, I guess. But yeah.